Hello students, welcome to Math 1325 Applied Calculus. Lesson 0 covers only the preliminaries, so if you feel comfortable, just skip it and go over to Lesson 1. Now if you do decide to stay, then remember all these are preliminaries, so it's okay to skip anything and do this in any order. Roughly speaking, Section 1 covers algebraic preliminaries from pre-algebra and basic algebra. And Section 2, some intermediate algebra and advanced algebra. Of course, not the entire courses, just some selected topics. Now, Section 3, geometric preliminaries, and these are coming from various courses. Let's begin. Let's go to subsection 3.1, lines. And these are the equations of lines that you have to know. There are more, but these four are essential. Here's a general form. Any linear equation, any first-degree polynomial equation of x and y form a line. The general form, ax plus by plus c equals to 0, or flip this one to the other side and express it as ax plus by equals to some number. Either way is a general form. Here's a visualization, and this program is randomized, so you can run it again, and you're going to get a little bit different. Run it again, something still different. You have all those A, B, and C values. Now, from the general form, let's copy and paste this. Okay, from the general form, you can solve for y as long as b is non-zero. If this is 0, then this part just drops out, and there's no y term, so you cannot solve for y. If b is non-zero, then this one stays, so you can solve for y. by is negative ax minus c, like this, after flipping this ax to the other side and also plus c to the other side, and then divide by b. Yes, we can do that because we assume b is non-zero, remember? If b is 0, then of course I cannot divide by b, so you can't do this. But then again, if b is 0, then this is 0y, so there's no y term, so there's no need to solve for y at all. Anyway, if you get this, so that y equals to this number times x plus that number like this, then that is called the slope-intercept form. This number is called the slope, and this number here is called the y-intercept. Here's a visualization. So m is, in this case, negative 0.548 something, and b is 1.591. So this one is a y-intercept. That is, this point where the line cuts through the y-axis, and that y-coordinate is the b value here, 1.591. You can easily see that by plugging in x equal to 0, so that this part just drops out, y equals to b. Now that's a y-intercept, and this one is called the slope. That is, as I move one unit to the right, I go up by m. In this case, negative 0.45548. So I go up by negative 0.548. That means I go down by 0.548. Not surprisingly, the graph is going down. The line is headed downward. Let's run it again. What did I get this time? Not too different. Another downward line. Okay, this time line is going up. So m is positive. As I move one unit to the right, I go up by 0.57696. Okay, about that. And then b value is pretty close to 0. And this y-coordinate here, where this graph is cutting this y-axis. But if it is really 0, then it'll have to go through the origin. Okay, so much for slope-intercept form. Now, the SlopePoint Form. And this is the most important for our course, so I highlighted with this box. And an equivalent form for this is y minus y0 is m times x minus x0. Please note that this form and that form are equivalent. Here, if I subtract away y0 from both sides, then I'm going to get this one here. And vice versa. From here, if I add y0, I'm going to get it over here. So this form and that form are equivalent. Either this way or that way, you have slope m and running through the point x0, y0. Here in this visualization, this point x0, y0 is negative 1.717, negative 0.823, this point. And then the slope is 0.5027, so as I move one step to the right, I go up by 0.502 something. So running through this red point and slope like that. Let's run it again, and then we end up with this one. This time slope is negatives, so graph is going down and running through this point, x0, y0. This form is going to be the most useful one, as far as this course is concerned, of course. Now, we have two equivalent forms. Me personally, I like this one better, but if you like this one, go ahead and use that one. I don't mind either way. Let's go back to where it was, because this is the form I personally prefer. Now let's go to two-point form. It looks like this. From this SlopePoint form, instead of x0, y0, let's call those x1, y1, because we want 2 points, x1, y1, and x2, y2, first point, second point. So it's running through x1, y1, so running through x1, y1 like that. Same place, instead of x0, y0, we have x1, y1 because it runs through x1, y1. And look at the slope. Slope is rise over run, so it's the difference of y coordinate over difference of x coordinates. y2 minus y1 over x2 minus x1, like this. Here are a couple of points, x1, y1, x2, y2. And then the slope is, as I move horizontally, x2 minus x1, so difference of x coordinate, I have to go up by y2 minus y1 like this. So difference of y coordinate. I'm going down because that difference is negative. So that's a two-point form. You can deduce it easily from the SlopePoint form. Plug in 1 point, x1, y1 there, and then use the slope formula, or rise over run, difference of y coordinate over difference of x coordinate. Okay, so much for the equation of the lines. Let's keep this one alive because that's the most important and useful. And let's go to some exercises on parallel lines and perpendicular lines. Two lines are parallel if the slopes are the same. For example, find an equation of the line that runs through a point negative 3, 1 and parallel to this line. Alright, running through this point, so it's gotta be this, the SlopePoint equation. And running through negative 3, 1, so okay, minus a negative 3, 1. And of course, nobody writes like this. I don't need this. And more importantly, minus, minus, we actually have plus. Okay, now what's the slope? It has to have the same slope as the original line. That has slope 1/2. So that's got to be my slope here. That's the answer. Well, there you go. And if you break up the parentheses and take the like terms together, then you're going to get the SlopeIntercept equation. If the problem asks you to do that, then go ahead and do it. Otherwise, you can stop here. By the way, here is, don't pay too much attention to these. Sorry, don't pay too much attention to this mathematical code. Anyway, why did I end up with this? Never mind. So, this line we found out, that's a red line here. And the blue line is the original. It's running through the origin 0, 0. And this red line is running through -3, 1. And as you can see, they are parallel. Now let's go to the next problem. Two lines are perpendicular if the product of their slope is -1. So basically we are talking about something like this. Times so new slope times old slope is -1, or equivalently, new slope is -1 over old slope. All I have to do is flip this one to the other side. We get the negative reciprocal. So let's go to this problem. The line running through this point, -3, 1, and perpendicular to this. Okay, all right. So it's got to be something like this. So running through -3, 1, substitute like this, and then of course nobody writes like this. There you go. And what's my slope m? Well, new slope is -1 over the old slope. So -1 over, what's the old slope in this case? There, it's 1/2. So that is -2, isn't it? Multiply 2 to both numerator and denominator, and you get -2 over 1. So that's -2. So there goes the line that's running through -3, 1 and perpendicular to this original line. Let's see. Here's the answer. Here's the visualization. So running through this point, -3, 1, and perpendicular to this original line. And yeah, there you go. Previously, I had parallel line like this, going this way. Okay, what about the next topic here? Horizontal lines and vertical lines. Okay, horizontal lines have slope 0. So y equals to 0, x plus b. So that one drops out, so we have just y equals to b. As you can see in this picture. Okay, it's just horizontal line, rise over run. No matter how many units I run to the right, there's no rise. Does not go up. Horizontal line. So whenever you have y equals to something, that's a horizontal line. You can rewrite it as y equals to 0x plus that something. In any case, horizontal lines do have slope. The slope is 0. Vertical line, on the other hand, has no slope. You get x equals to something, as you can see in this picture. So you see, all these points on this blue line shares the same x-coordinate value. Put all those together, then I get a vertical line. And then there's no y, so you cannot solve for y. If you have slope-intercept equation, then you have slope, but there's no y, so you cannot solve for y. There's no slope here. Also, if you do rise over run, you cannot run. There's no run. There's no horizontal motion, no matter how many units you rise up or down. So you get something over 0, basically. Denominator 0, so no slope. Slope is undefined. Sometimes people get confused here. Horizontal lines do have slopes. That's 0. Vertical lines have undefined slope. They're different. Okay, so much for lines. We'll discuss other subsections in separate videos.